Okay, so today we're going to start talking about inclusion exclusion, and this is not a difficult topic in its like basic idea, but it can get kind of difficult as we go forward with it. So let me start with the most basic thing, which I'm just going to call inclusion exclusion. And this is going to be inclusion exclusion for two sets. And this is just if I have two sets, A and B, then I have the size of A union B is equal to the size of A plus the size of B minus the size of their intersection. And I really don't think this is very difficult to grasp. And I want to just kind of give you a picture proof. We'll prove this formally later, but I want to give you kind of a picture proof. And that is, I'm going to draw a Venn diagram where here's A and here's B. And then if I want to count the number of elements in A union B, that's the number of elements in this, sort of doubled region. I always call it the MasterCard shape. Then I'll count everything in A. Then I'll count everything in B. But I notice that I've counted A intersect B twice. So to count the size of the union, I want to count each region one time. So I count A once, I count B once, and I have now overcounted this part. And in overcounting this part, I need to remove it then. So I need to remove A intersect B. Okay, so that's just the basic idea between inclusion and exclusion for two sets. So now let's do some inclusion exclusion problems that are relatively straightforward. So example 1. Let's say that I have 10 apps on my phone. Five are free, and 7 are games. Now, obviously, the only apps worth paying for are going to be games. All right, there's no point in buying an app if it's not a game, right? Nobody doesn't know that. Okay, so the question is, how many free games do I have? Okay, so how many free games do I have? And I wrote this so well, super pro handwriting. Well, let's do it like this. I'm gonna say, F is the set of free games, and G is the set of F is the set of free apps, and G is the set of games. So F intersect G will be the free games. So F is gonna be free apps, and G is going to be the set of games. So I'm looking for F intersect G. Okay, well, I have this that I have 10 total apps, so I know from this first fact that the size of F union G is equal to 10. Okay, 5 are free, so the size of F is equal to 5. 7 are games, so the size of G is equal to 7, and I want to find this. I want to find the size of F intersect G. Okay, so we just write in the size of F union G is equal to the size of F plus the size of G minus the size of F intersect G. And this is just by the inclusion exclusion formula. And I plug everything in, and I've got 10 equals 5 plus 7 minus the quantity I want, F intersect G. And by doing some arithmetic, this gets me that F intersect G is of size 2. And that's my final answer. All right, so I think that's a pretty straightforward application of the inclusion exclusion formula. And I feel like you probably didn't need this formula or even Venn diagrams to reason through this in your head. But this is just to show you sort of a basic way that it works. Okay, so let's try to do some more complicated examples. So, next example, we're going to consider what I'm going to call brackets 100, and this is 1, 2, ... up to 100. This notation, maybe I'll introduce it more formally later. If I put brackets around a natural number, I mean the interval of natural numbers 1 up to that number. So I'm just telling you what it means here. Consider the numbers 1 to 100, and I've got 3 questions. So question part A, how many are even? Part B, how many are multiples of 3? And so part C then is how many are multiples of either 2 or 3. So it's all right, so solution. So for part A, what do we want to do? Well, we want to just see how many are even, and you probably already knew this before I even finished writing the question. The answer is 50, but let's slow down a little bit and try to get to 50. So how do we get to 50? Well, we're going to take 100 and divide it by 2 and take the floor. Why is that? Because every second number is even. So 100 divided by 2, take the floor, gives me 50. Okay, so not that hard. Part B, how many are multiples of 3? Well, again, we're going to take 100 and divide it by 3 and take the floor. And why are we taking the floor? Because the first one is not a multiple of 3, the second one's not a multiple of 3, the third one's a multiple of 3. So I'm looking for the number of triples, but I'm rounding down. It only counts if I get an even multiple of 3, right? So this should be 33 multiples of 3. Now for part C, what I need to find is not multiples of 6, because that would maybe seem to be the next answer, but multiples of 6 is going to be part of the question. It's how many are multiples of 2 or 3. So what I'm going to do is I'm going to call this set A, the evens, and I'll call this set B, and this is the multiples of 3. And then C is really asking us how many are multiples of 2 or 3. C is really asking us now, what's the size of A union B? Okay, so I need to find the size of A union B. I've got A, I've got B, and if we go back up to our inclusion-exclusion formula, if I want to find the size of A union B, I need to have A, I need to have B, but I also need A intersect B. So what is A intersect B for this question? A intersect B for this question is going to be, part C here, I'll just write it down. To find A union B, the size of A union B using inclusion-exclusion, we'll need the size of A intersect B. And what is the size of A intersect B? Well, A intersect B is going to be even multiples of 3. Those are also known as multiples of 6. So, using the method we used before, we find that the size of A intersect B is 100 divided by 6. Take the floor. And this should be whatever 100 divided by 6 is. So what's 100 divided by 6? Let's find the biggest multiple of 6 that's less than 100. So 60 gives us 10. We've got 40 more. So 36. This tells me there are 16 multiples of 6. Okay, so you have to be a little bit careful. It's, I guess it's not that hard to do in your head, but whatever. So now I plug all of this into the inclusion-exclusion formula. So I'm going to use the same formula that we've been talking about this whole time, inclusion-exclusion, and let's put it in. A union B has size equal to the size of A plus the size of B minus the size of A intersect B. So let's plug in what we know. We plug in what we know. We get that A union B, which is what we want, is, well, I've got A is 50 plus B is 33. Size of A is 50, size of B is 33, minus the size of A intersect B, so minus 16. And if we do the arithmetic here, we've got what, 83 minus 16, 73 minus 6, and this gives me a total of 67. That's my final answer. All right, so hopefully this gives you some idea how to do some basic inclusion-exclusion problems.